Good morning, students. In last class we have studied about the pH. To determine pH, there is a formula. The formula is pH is equal minus log of concentration of hydronium ion. I mean the value of pH, it mainly depends on the concentration of hydronium ion. If you know the hydronium ion concentration, then you can find out the value of pH, and from the pH value you can identify whether a solution is acidic, basic or neutral. As you know, acid always produce hydronium ion and base produce hydroxide ion, OH minus ion. If you want to determine pH for a base, so how do you determine? Because base do not produce hydronium ion. So for base, you can determine pOH. pOH is equal minus log of concentration of hydroxide ion. And there is a relation between pH and pOH. The relation is pH plus pOH is equal 14. So for base, if some bases are given, first time you find out pOH for the base, because from base you will get the concentration of hydroxide ion. So you determine pOH value. After determining pOH value, you do 14 minus pOH, you can convert to pH. So pH mainly depends on the concentration of hydronium ion, and there is a scale of pH. The scale start from 0, this is the pH value, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the pH scale. It starts from 0 to 14. If the pH value is 7, you know the solution is said to be neutral. And if the pH is less than 7, then the solution become acidic in nature. And if the pH value is more than 7, then the solution is basic in nature. This pH value, whether it is 1, 2, 3, 4, 5, 6, 7 or 8, it depends on the concentration of hydronium ion. If these are the concentration of hydronium ion, if the concentration of hydronium ion is 10 to the power 0, then you will get pH 0. If the concentration of hydronium ion is 10 to the power minus 1, I mean 0.1 molar, then you will get pH value 1. If it is 10 to the power minus 2, you will get pH value 2. If it is 10 to the power minus 3, you will get pH value 3. If concentration of hydronium ion is 10 to the power minus 4, you will get 4. Similarly, 10 to the power minus 5 gives 5 value. 10 to the power minus 6 gives 6 pH value. And if 10 to the power minus 7 concentration of hydronium ion, then you will get pH 7. In ionic product of water, you have got, if hydronium ion concentration is 10 to the power minus 7, then the solution is said to be neutral. Then you will get the pH value 7. For 10 to the power minus 8, pH value will be 8. 10 to the power minus 9 concentration hydronium ion gives pH 9. 10 to the power minus 10 will give 10. 10 to the power minus 11 will give 11 value. 10 to the power minus 12. 10 to the power minus 13. And for 14 it will be 10 to the power minus 14. So this is the scale of pH. pH value mainly depends on the concentration of hydronium ion. Based on the concentration of hydronium ion, you will get the pH value, and from the pH value you can identify whether a solution is acidic, basic or neutral. Now here you have seen the concentration of hydronium ion. These are given 10 to the power 0, 10 to the power minus 1. 10 to the power minus 1 means 0.1 molar. 10 to the power minus 2 means 10 to the power 10 to the power minus 2 means 0.01. This is 0.001, like this. I mean, this pH scale concept, this is applicable only for dilute solution. I mean, the solution whose concentration is low. For higher concentrated solution, this pH scale is not applicable. So this scale is applicable only for dilute solution. I mean, the solution whose concentration is very, very low. Now, as I have told you, To determine pH, it mainly depends on the concentration of hydronium ion. When you take logarithm of concentration of negative logarithm of molar concentration of hydronium ion, concentration must be in molarity, then you can find out the pH. We will do some numerical, then you will get the idea. And if your substance is base, first time you determine pOH for the base, then you do 14 minus pOH, you can convert to pH. Now as I have given the relation pH plus pOH, it gives 14. So how the relation come? So that relation I will give you. Relationship between pH and pOH. That relation I will find out. Relationship between pH and pOH. In ionic product of water, in last class we have done, you have got a relation concentration of hydronium ion into concentration of OH minus ion. This is equal Kw. We know it. Already you have got this relation. And at 25 degrees Celsius, concentration of hydronium ion into concentration of OH minus ion is equal 1 into 10 to the power minus 14. We have got at 25 degrees Celsius, the value of Kw is 1 into 10 to the power minus 14 at 25 degrees Celsius. Experimentally, it is found. Now, taking negative logarithm on both sides of the equation, minus log of, दोनों साइड में माइनस लॉग लेना पड़ेगा, कंसंट्रेशन ऑफ हाइड्रोनियम आयन इनटू OH माइनस आयन, दिस इज इक्वल माइनस लॉग ऑफ 10 to the power minus 14. Log of A into B, you can write log A plus log B. Ultimately you can write minus log of concentration of hydronium ion plus minus log of concentration of OH minus ion. Minus log of 10 to the power minus 14 means the value will be 14. If it is log 10 to the power 2, value will be 2. If log of 10 to the power minus 3, value will be minus 3 like this. The power term will be the value. If it is 10 to the power minus 3, 10 to the power 2 like this. Here it is 10 to the power minus 14, so value will be minus 14, but here another negative present, minus minus plus, that's why the value is 14. As you know, minus log of concentration of hydronium ion, you can write pH. Minus log of OH minus ion concentration, you can write pOH. This is equal, you can write 14. So this is the relation between pH and pOH. The pH and pH, the summation of pH and pOH is always equal to the 14. So if you determine pH, you can convert to pOH. If you determine pOH, you can convert to pH also. So if your substance is acid, directly you can determine pH value, because acid always produce hydronium ion, so you can find out the hydronium ion concentration. And if the substance is base produce OH minus ion, so you put the concentration of OH minus ion, then you will get the pOH value. Then you do 14 minus pOH, you will get the pH value for bases also. So for acid, directly you can determine pH, and for base, you determine pOH first time. See, here if you do not put the value 10 to the minus 14, I mean concentration of H3O plus into concentration of OH minus is equal Kw. If you take negative logarithm on both sides of the equation, then this become pH, this become pOH, this Kw you can write like this, pKw. This is another relation. In terms of Kw, you can write pKw. I mean, the value of pKw is nothing, that is 14 at 25 degree Celsius. This is another relation in terms of Kw, and when you put the value of Kw, then the equation goes to pH plus pOH is equal 14. So you can write the equation, you can write the relation in this way also, in this way also. If you put the value of Kw, then you will get 14, and if you remain this as KW, then the relation goes to pH plus pOH is equal PW. I mean minus log of KW, this you can write as PKW. That's why I have written PKW. As minus log of H plus gives pH, minus log of OH minus gives pOH. Similarly, minus log of KW, it gives PKW. So this is the relation between pH and pOH.